Alright, in this video tutorial, we will learn how to write functions in our environment. But the first fair question is, what is a function and why do we use functions? A function is used to avoid repeating tasks multiple times. A function takes an input, executes a series of commands on them, and then returns output. The functions in R can be classified in two categories: built-in functions and user-defined functions. You are familiar with built-in functions in R. For example, minimum, maximum, median, a standard deviation, mean, sequence. They take inputs or inputs, do some tasks on them, and return output. Okay. So let's say I have a vector. For example, I have a vector x has the values of 0, 1, 5, 2, 4, and 6. Okay. And I want to find the arithmetic average. So if I want to find the arithmetic average, I have to add them up, which means 0 plus 1 plus 5 plus 2 plus 4 plus 6, and then divide everything by sample size, which here is 6 observation, 1, 2, 3, 4, 5, 6, which will return the value of 3, which is the average, right? But instead of this operation, I could use the function mean that gets an input, which is our x, does some operations behind the scene, which is add them up divided by 6, which we don't see it, but it will return a value, which is going to be 3, right? Or, for example, standard deviation. So we know that a standard deviation is on average, what is the deviation of observations from mean of observation, right? So we have mean here, and each observation from mean, okay, so it's going to be 0, which is this observation from the mean, minus 3 squared, plus the second one is 1 minus 3 squared, plus the third one is 5 minus 3 squared, plus 2 minus 3 squared, plus 4 minus 3 squared, plus 6 minus 3 squared. Okay, so, and if you calculate this and then divide the entire thing by n minus 1, which is 5, right? So, and then if you take a square root of everything, which means that to the power of half, right? The entire thing to the power of half. So I will have a standard deviation, which is going to be 2.36. But instead of that, I could easily use SD, standard deviation of x, which gives us the same value, okay? So instead of calculating the standard deviation like this, deviation of observation from the mean, which was 3, using this formula, I just use the function SD, which gets input, which is your here, this vector, and then do some process behind the scene, which is this one, and then output, which is standard deviation 2.36. Imagine you have to find mean or a standard deviation of different data, like 100 times in your code. So if you use this formula, if you want to use this formula or this formula for mean or standard deviation 100 times, it can be very time consuming, right? It can be very complex tasks, okay? But rather than that, if you use function, for example, mean or standard deviation like this, if you write the function or if you use, so these are built-in functions in R. If you use this one, you can save your time, your code can be much more efficient, and it will be much easier to understand, okay? So functions are particularly useful when you want to perform a series of tasks multiple times. For example, you want to calculate standard deviation multiple times in your code, mean multiple times in your code. But there are a lot of built-in functions in R, like mean, standard deviation, minimum, maximum, sequence, for example, SEQ, right? The function can get a value from 1 to 100 and with a step of 0.1. Okay, so it can produce this one. So this one is a function. All of these are built-in functions in R. But R doesn't cover all of our needs, okay? And there are some tasks that there are no functions for them, okay? So using functions, you can customize and extend our language. In this video, we're going to learn how we can write our own functions for our own particular needs. Okay, so the general syntax for function is, first of all, you have to first begin with the keyword function, okay, and then follow up by parentheses, and within the parentheses you will have your input arguments, okay. So you can have no arguments, you can have one input argument, or you can have multiple input arguments. And here, so you will have your arguments, okay, args, and so it can be 1, arg2, or more arguments, and then open and close the curly brackets, and within the curly brackets you say that you do some tasks, okay, and then return the output. We will use the keyword return the output. So that's the output or outputs. That's how a function works. And then you have to give the function a name, okay. So you have to assign a name to a function. For example, function 1, okay. So, and when you want to use it, you will have, for example, so here you have to call the function 1, and then give some input to it, for example 12 and 11, so it does the calculation for us, okay, like the standard deviation, for example. So let's see a couple of examples to learn how we can write functions in R. I want to write a function, okay, I want to write a function that gets a number and determines if it's an odd number or even number. We know that an even number is a number that when we divide it by 2, the remainder is 0, okay? Otherwise, it's going to be an odd number, okay? So I begin with the word function, and I'm going to get an input like x. And here, I will say that if x modulus 2 was 0, okay, if this was true, then what happens? Then return even, okay? And else, so here, if this doesn't happen, return odd, okay? So that's, so this parenthesis for else, and this one is for function, okay? Then what else we have to do? I have to assign a name to this function. So I'm going to call it, I don't know, even underscore odd. So this is a function that when I call this function, it will determine whether it's an even number or an odd number. Okay, so if I run this line of code, if I go on this line, the name of the object, put my cursor here, and then click run, in the functions, I can see that we have a function called even underscore odd. So now how can I use this function? So even, so we can see that even underscore odd, and now it requires an x, it requires a number, for example 12. Okay, so if I run this, it returns even, because 12 modulus 2 is going to be 0, so it will return even. How about 121? Odd. Okay, so it can be any number, doesn't really matter. So we don't have to repeat this process a lot. I just call the function and it will do the calculation for us. Okay, so it will save our time. It is more efficient to write function in R. So what happens is that it takes a value and does some operation on it, and then it will return something. For example, here it's even or odd. Next, we want to write a function that gets the radius of a circle and calculates its area, okay? So I'm going to write a function, gets a circle or radius of a circle, and then I have to open and close the curly bracket, and then so returns the area. So I'm going to call this area, which is pi times r, right? And then it will return area. So again, don't forget that you have to assign a name to the function, for example, area.circle, okay, and then run it. You can see that it will be added to the functions part. So now if I call this function area.circle and I give it a value, for example, 12 or 4, okay, so it's going to be 4 times 4 times pi, okay, so it's going to be 50.26548, okay. So the input, so it can easily return the value. You can easily write, for example, instead of this one, if you wanted, you could just do the calculation here, okay, return pi times r times r. So it could be simpler. So here, the input of the function is not just a single value, okay, so it can be a vector. For example, if I have a vector like x, a sequence from 1 to 10 by the steps are 0.2, okay, so this is x. So if you want to see x, this is x. And I'm going to calculate the area for x. I'm going to apply this function for each element in this x. Okay, so if you run this code, you will see that it calculates the area for this, for each element in this vector. Okay. So far our functions had a single input and returned a single value. Okay, but your function can have multiple input arguments and can return multiple outputs. Okay, for example, I want to write a function that takes lengths and widths of this rectangle and calculates its area and perimeter. Okay, so again, I will begin with the keyword function. It gets 2 arguments, for example, L and W. Doesn't really matter what the names are. And then open and close curly brackets. So here I'm going to say that the area of the rectangle, we know that it's L times length times width, right? So here area is L times W, right? Takes L and W and multiply them. And then also I'm going to mention that perimeter equals to 2 times L plus W, right? So that's going to be the perimeter of the rectangle. And I'm going to say that I'm going to return area and perimeter, right? So return. So if I type area and perimeter, so you will get an error, right? So why? Because this is 2 values, so we have to combine these 2 as a vector. So I use a C for concatenation, and then it will return this, return area and perimeter. Okay, so if I, again, don't forget that you need to assign a name to this function. For example, this is rectangle area dot perimeter. Okay, so that's the name of the function. So this is the name of the function, gets L and W lengths and widths. So for example, now if I call this function rectangle area perimeter, so you can see that gets 2 arguments. Okay, so for example, 2 and 3. Okay, and then 6 and 10, return 6 and 10. 6 is going to be area, but which is 2 times 6, 2 times 3, and perimeter is going to be 10, which is 2 times 2 plus 3, okay, which is 10. But it is better to have a name when you return this, right? Because we don't know which one is area, which one is perimeter. So I can add, for example, here I can add word area equals to this value. So this one will be written in the output. Doesn't matter what is that. It's not an object, it's just a name. Perimeter equals to, okay, perimeter. So what's going to happen if I again run this line of code? And if I run this line of code, I can see that it shows me that area is 6 and perimeter is 10. Another way, so instead of vector, I could return it as a list. Okay, so if I return this as a list, let me run this line of code. So it's going to be another way for returning the output of a function. Another thing is that you can assign default values to arguments in a function. Okay, for example, I want to write a function that gets a and b two numbers and raise a to the power of b. Okay, for example, gets 2 and 3 and raise 2 to the power of 3. Okay, something like that. But if I only input just one value, the default value is going to be 2. Okay, so if I don't mention two values, the default value, it assumes that the second value is 2. Okay, so it's very simple. So I can write a function that gets a and b, but here I can, set the default value that is 2. If we don't specify the value, it will consider this as 2. And then a function, for example, which is going to be, so let me go to the next one, a to the power of b. So it gets a and b. So this is going to be our output, or I can easily return it here. Okay, return a to the power of b. Very simple. Okay, and I just want to call it, I just want to assign it to an object, for example, a power b. Okay, so this is a function, another function. So what happens, for example, if I call this function a power b, so for example, 2 to the power of 3. If I run this, it's going to be 8 to the power of 3. But if I just mention 2, so the default value is going to be 2. So it's going to be 2 to the power of 2, which will return the value of 4. Okay, so it is optional to have default values. For example, here I can have default value for a as well. Okay, so if I, for example, 4, okay, and if I run this line of code and don't mention anything, what's going to happen? 4 to the power of 2. Okay, so it just uses the default values. Another thing is that functions can be nested, which means that you can define a function inside another function. Okay, so for example, I'm going to write a function that gets a vector and a vector of numbers and normalize it. Okay, so we know that the formula for normalize is that the value minus the mean of the vector divided by a standard deviation, right? So the way that it works is I'm going to write a function, right, that gets a vector like x, right? And then here I'm going to say that first of all I'm going to find the mean of x, mean of a vector. Okay, so it's not just the value mean of x. I'm going to say that ignore the null values, right? For example, if there are na, just remove them. na.rm, I'm going to set this to true. Okay, so let's call this mean of x, mean.x. Okay, that's the finds the mean of the values, mean of the for a vector. And then also I'm going to find the standard deviation of x. Again, if there were null values, just remove them. And then I'm going to also call this as st.x, right? So the next thing is that I'm going to find, so I have the mean of x, I have the standard deviation of x, so it's going to be x minus mean of x, which is mean.x, divided by the entire numerator divided by standard deviation of x. So I'm going to return this value, right? So let's see what's happened. So it will normalize a function. Okay, so let's say, so first of all, so I have to call this, put a name for the function. Oh, sorry, a name for the function normalize. Okay, so let's run this line of code, normalize, and let's give it a vector. For example, x is, it's not just x, it can be anything. Okay, so it can be any name. Okay, z equals to a sequence from 1 to 5 with the steps of half, right? I'm gonna apply the normalized function to the z vector. So what happens is that for 1 divided by mean of this vector, mean of x, 1 minus this one divided by standard deviation of this vector. So it normalizes the values in this vector. So it will apply normalize for each item in this vector. And another way, so that's how the normalize works. Another way is instead of showing this as a vector, I can return it as a, for example, a data frame, okay? So here if I type data.frame, so it's like list. I could return it as a list, but also you can return it as a data frame, okay? And data frame, and then I have to close this parenthesis, okay? So now it will return it as a data frame like this. But another, so here I have the values. So let me see, 1 to 5 steps are, but I'm also want to show the x, right? I don't want just the result. I want the x as well. So I want to return x and the normalized value, okay? Normalized return or z. So I have the x values 1, 1.5 until 5, and then I have the normalized value. So this one doesn't look good, so I'm gonna just give it a name, right? For example, like area, like perimeter, that we assigned a name, just people can understand the output. So here I'm gonna name it, for example, normalize. Okay, it can be any name. Normalize is this value. So now if I run this line of code, z and normalize, so I have the x, and then I have the normalize of x. Okay, so 1 normalizes this value. 1.5, the normalized value is this value, and so on. So that's how you can write functions in R programming language.